9.1 Introduction to Geometry, Points, Lines, and Planes. Okay, today our objective is to identify geometric figures involving points, lines, and planes. What we're really talking about here is Euclidean geometry, and that's a branch of mathematics that includes the study of shape, size, and other property of figures. It is probably one of the oldest branches of mathematics, probably even used in prehistoric times, like in the Flintstones. Do you even know what the Flintstones are? Really, they didn't exist, just in case you didn't know. Okay, and Euclid, that's where Euclidean geometry came from, wrote the book The Elements around 300 BC. BC stands before Christ. Okay, so it's been around a long time. So on your paper, let's start with a point, and let's call it Q. And a point designates an exact position in space. And really, when you're talking about a point, it's supposed to be as small as it can be, so it really should be not seen, but obviously we have to make it so we can see it. Otherwise, there's not much point to it. And let's do another point and make it P. And we're going to draw a line that goes all the way through it with arrows at each end. So it needs to go past the 2 points and put arrows at both ends. And that's a line, and it's at least 2 points determine a line, which is an infinite set of points forming a straight path in 2 directions. So that's a line. And we can call it line PQ or line QP. And to show you that it's a line, you're supposed to put a line above the PQ or the QP. Again, with arrows at both ends. Let's do another point. We'll call it T. And let's draw a line that goes from point P through T with an arrow at one end. So rays have exactly one endpoint and extend indefinitely in one direction, so they go on forever. Let's connect Q to T straight with no arrows. That's known as a line segment, and when we identify it, we put just a line with no arrows up top. And line segments have exactly 2 endpoints, so they have a beginning and they have an end. Now, if you were to put those, basically imagine that green as like a sheet of paper. That could be called the plane QPT. And it's like a piece of paper in space. You need 3 non-collinear points to determine a plane. And we'll talk about collinear in a moment. Okay, use the figure below to name the following. So I want you to try to name one line. So looking at this figure, what do you think could form a line? Go ahead and write it down, or in your head think about it. Okay, one possibility could be the line AB. Again, put the line with the arrows up top. We could also flip it around and call it BA, or we could say BC, or CB, or AC, or CA. All of these are potential names for a line. Now, would you take a moment and try to name 4 different line segments? So you're looking for 4 line segments anywhere on the line. Please pause the video and try to write down as many as you can. Okay, some possibilities. Could be BC, we could have AC or AB. I'm going to flip it around. I'm not going to. We also have BC. Or sorry, I said that one. AC, I believe, is what we're looking for there. And CA. We could also have BD or DB. So there's 4 potential line segments. Now we're going to name some rays. We could have ray BC. We could have ray BA. And again, you want to make sure that you start with the where it ends. So this one we're going to want to have the first letter be the first thing. So BD, AC, or AB, and we could have CA or CB. Okay, collinear and non-collinear. Collinear is when a set of points could be on the same line. So if you can draw a line through it, they're collinear. Non-collinear would be the opposite. They're in a random order, when a set of points cannot be on the same line. Any 2 points will always be collinear because you can always draw a straight line between 2 points. It takes at least 3 points to be non-collinear. Parallel lines and perpendicular lines. Parallel lines are in the same plane that do not intersect. So if you imagine this as a sheet of paper, they never touch, they never end. And to show that two lines are parallel, you draw two parallel lines vertically in between the names of the two lines. Perpendicular are lines that meet, so they intersect, they cross, and form a 90-degree angle. This could be a set of perpendicular lines. They form 90-degree angles. To show that it's 90 degrees, you kind of do an upside-down T, so that it looks like it's like the side of a wall or something, and you can kind of see the 90-degree angle. Skew lines, I like the word skew, are lines in different planes that do not intersect and are not parallel. Okay, so I have that, and then that. The two red lines do not touch, do not intersect, and are not parallel. Okay, so let's use the figure to find the following. Two pairs of parallel lines, two pairs of perpendicular lines, two pairs of skew lines. Will you pause the video and try to list out all that you can? Okay, so parallel lines could be AB and CD. They're parallel. And GC and HD. Now these aren't the only sets of parallels, they're just two examples. We got many sets of parallels that we could use, or many examples. Two pairs of perpendicular lines could be AB again and BC. We could have EH is perpendicular to GH. Skew lines, we could have AD is skewed to GH. Notice how they're not parallel and they're not touching. We could do EH and FB. And that's it for today. If you have any questions, post them on Edmodo or come by class and I'll be happy to help you out. Thank you very much.